Welcome to Study Loop.
We'll be using conservation of energy to determine the minimum speed with which a lead bullet was fired, such that it entirely melted upon impact with a door. So the lead bullet has a mass of 7.2 grams. We'll put that into kilograms. And it is lead, and it melted entirely. And we're going to be using conservation of energy. So we'll start off with the work energy theorem, with the understanding that it was friction that did negative work upon that bullet to stop it. So this is friction is equal to change in kinetic energy is 0 minus 1/2 v initial squared. And that work that friction did, we're going to assume 100% of the work went into heat absorbed by the bullet. Okay, and we are going to, and that may not be a very good assumption, but we are finding the minimum speed. And that heat absorbed went to two things. It first went to raising the temperature of the bullet to the melting point. So M is the mass, C is the specific heat capacity, which is a property of lead that we can look up, 128 joules per kilogram per degree centigrade. We need to know how high it had to go to get to a melting point. And the melting point of lead is determined to be 327 degrees and a half. And the initial temperature, of course, was 20 degrees centigrade, room temperature, plus or minus maybe a few degrees, depending on how hot the day was. And then there's the energy needed to melt the bullet once it gets to the melting point. And that is a quantity called the latent heat of fusion, which again is a property of the lead, which, looking it up, the latent heat of fusion for lead is about 22,400 joules per kilogram. Okay, so we are going to equate the positive heat absorbed to 1/2 mv squared. Again, this is the most unrealistic thing, is to say that all the heat all the kinetic energy went into heat in the bullet, when some of it would have gotten into the door and left burn marks, etc. But oh well, let's figure out the initial speed. Okay, from the other parameters, which we can look up. And what's interesting is the mass of the bullet actually cancels from side to side. And solving for the initial speed squared, 2 times 128 times temperature difference, 327.5 minus 20. That's in degrees centigrade. Then the latent heat of fusion. Okay, and working that out. Oh, and there's 2 in front of that as well. Yeah. Leave some room there. And that would be units of joules per kilogram or meter per second squared. Yeah, that's a good set of units. And working that out, let me check one more time. Lots of numbers to check out. Yeah. One intermediate step down here. The square of the initial speed is quite high. And taking a square root, we get of the order of 351 meters per second, which seems like a reasonable value. It's very close to the speed of sound in air, and that is typically a limiting factor in firing a bullet.